Okay, so let's start today's deep dive by forgetting the giant industrial plants for a second. We're going to zoom way, way in, down to a single, highly specialized component, one that kind of dictates the purity and efficiency of huge global supply chains.
Yeah, we're talking about electroformed nickel screens, and the
Mhm.
source material for this is fascinating. It's from a specialized manufacturer in India, a company that's been honing this specific craft since, what, 1969?
That's over 50 years.
Exactly. And the thing that really stands out is the commitment to purity. I mean, these screens are made from nickel that is 99.99% pure.
99.99. That's practically
That's
surgical level stuff. But it's working in some of the heaviest, grittiest industries out there. So, okay, what is their core job? What's the mission?
Their whole job is separation and filtration, specifically inside what are called continuous centrifugal machines.
Right.
So the classic example is a sugar mill. You have these screens that have to handle immense force spinning incredibly fast to separate the tiny sugar crystals from all that heavy corrosive mother liquor, the molasses.
It sounds like it needs to be incredibly precise.
Absolute precision, and it has to maintain its shape, its dimensional stability under all that stress.
So if that's the mission, why this ultra-pure material? I mean, couldn't standard industrial alloys work,
Yeah.
even if you had to replace them more often?
Well, that material choice is really the key. It's all about longevity. They use a technology called electroforming.
Electroforming.
Yeah, which is essentially growing the screen atom by atom on a conductive surface. It allows for just microscopic precision.
You're basically printing with metal atoms.
You could think of it that way. And the result is a perfectly uniform thickness. We're talking sometimes thinner than a human hair, down to just 3 microns.
And that process gets you those
Mm.
conical slots, right? Why is the specific geometry of that slot so much better than, say, a standard woven mesh?
It's all about flow. Think of it like a perfect tiny funnel. These conical slots guide the liquid through so smoothly with minimal friction. It just speeds up the whole separation process. And this ultra pure nickel is also it's incredibly resistant to corrosion. It can operate in really brutal chemical environments, from pH 2 acids all the way to strong pH 12 alkaline solutions.
It just holds up.
It holds up without degrading or, importantly, without leaching anything into the product.
Okay, I have to ask about the cost, though. If the material is so specialized, the initial price must be significantly higher than standard stuff. How does that balance out?
It balances out completely through uptime and durability. That's the whole game.
So fewer shutdowns.
Exactly.
Yeah.
Unlike a woven steel mesh, the structure of this alloy, it just won't distort or warp under those huge centrifugal forces, so it lasts dramatically longer. That means less expensive downtime, less replacement labor.
And I noticed in the source material they mentioned a mirror smooth surface. In the sugar industry, why does the texture of the screen matter so much?
Oh, that smoothness is absolutely paramount. It's all about product quality.
Oh, so
When sugar crystals are spinning at thousands of RPM against a rough surface, they shatter, they break, and that just lowers the quality and consistency of your final sugar.
right.
The mirror finish minimizes that breakage. And for even more durability, some of them get a tiny 10-micron coating of chromium.
And what does that do?
It just boosts the surface hardness, what's known as hardness Vickers, or HV2 over 850 makes it incredibly tough.
So what's for operators is clearly maximizing uptime, but where else does this kind of micron level precision matter, beyond sugar?
Basically anywhere that purity is non-negotiable. Think pharmaceuticals. The fact that this nickel doesn't leach is essential for hygienic processing.
Makes sense. For drug standards.
Exactly. It's also used in things like textile rotary printing for these perfect, precise perforation patterns and desalination plants.
Because of the corrosion.
That superior corrosion resistance in saline environments is critical.
Which brings up a good question. If these are massive machines all over the world,
Well, they have to be. They meet and often exceed all the major international standards, ISO, ASTM, ANSI, all of those. They're engineered to be drop-in compatible with every major centrifugal brand.
so we're talking BMA, 5KL.
Yep, Thomas Broadbent.
Yeah.
It just makes the whole sourcing headache disappear for plant managers.
So when you step back and look at it, you have an Indian manufacturer specializing in a component that's micron thin, and yet their reach is global. They're exporting this foundation of industrial efficiency to places like Thailand, Mexico, Dubai.
It's the unseen infrastructure of purity, really.
It really is. It
Yeah.
just shows how these incredibly specialized, high-quality parts are essential for keeping everything running smoothly across entire continents.
It's amazing. A single, ultra-pure component dictating the precision, the purity, and the uptime of so many global processes.
Right. So as we wrap up this deep dive, here's a final thought, a kind of engineering challenge for you to consider. Given the extreme forces and chemical conditions these micron-thin screens endure, how does the precise geometry of one of those electroformed conical slots directly impact the global price stability of a common commodity, like sugar? Just think about that seamless nonstop throughput.